አድርጉኝ። ዛሬ ለሳምፕል ኤግዛም እናያለን። ሳምፕል ኤግዛሞች እናያለን። Let's start it. The first type is type 1, which is right, true or false. Depending on the statement, you will decide right, true or false. So the first question is, let x and y be a positive integers, then the truth value of this statement, for all x there exists y, x less than y is true. Have you seen? For all x there exists y, x less than y. What does it mean, this statement? For all x there exists y, means that for each choice of x we can find corresponding y such that the proposition is true, which means so x and y are from the set of positive integers. Then what is the statement? What will be the truth value for this statement? So this one statement. So x is less than y for every set in the set of positive integers. So can we find for all choice of x corresponding one says that x is less than 1? Clearly true. For every choice x is equal to 1, we can find y corresponding y, which is 2. And for x is equal to 3, we can find corresponding y is equal to 5. Or you can find corresponding value says that x is less than 1. So for every choice of x, we can find corresponding y in the set of positive integers such that the statement is true. Therefore, this statement is true statement. This statement is a true statement. The second question is, if x is the subset of b, if x is a subset of b, then A union B is a subset of B. Is it true or false? Have you seen this one? It's given that A is the subset of B. A is the subset of B. When we see it on the Venn diagram, A is the subset of B is here, saying that this one is the universal set, this one is the universal set. A is the subset of B is given, so A is inside here, A is inside here, A is inside here, A is inside here. So A is the subset of B clearly. Then what's A union B now? A union B. What's A union B? A union B is clearly B. A union B is clearly B, which is B is a subset of itself. B is a subset of itself. Therefore, this statement is also a true statement. This statement is also a true statement. The next question is, for any set A, implicit set is a proper subset of A. Implicit set is a proper subset of A. So any set and implicit is a subset of every set, but implicit is not the proper subset of any set. So it's a false statement. It's a false statement. So these ones are the true false parts of the mid-exam. And the second part is on type 2, choose the best answer. Choose the best answer. So the first question is about, it says that if P is always truth value, if P always has a truth value opposite to the Q, so you have given two opposite values. P is one statement and Q is another statement, and the truth value of P is opposite to Q, then the compound statement P implies P or negation of Q is what? So it's given that P is opposite to Q. Which means that negation of P is equal to Q. Negation of P is equal to Q. Negation of P is equal to Q. So the compound preposition P implies P or negation of Q. P implies P or negation of Q. So which means that P implies P or negation of Q is what? Negation of Q is P. P or negation of Q. So P implies P is what? P or P is what? P itself P. So P implies P is always what? P implies P is always a tautology. P implies P is always true. It's always true, therefore it's a tautology. It's a tautology. So P implies P is always true. Now the next question is, the compound statement P implies Q is false. It's given that the compound preposition is false statement. Then what will be the truth value of P and Q? What will be the truth value of P and Q? This is that. So the compound preposition is given. the compound preposition P implies, which is the second question, P implies Q, is given that P implies Q is given that a false compound preposition, a false compound. Then what will be the truth value of P and Q? So, which means that P implies by using equivalence, negation of P or Q. Yeah? The equivalence of P implies Q is negation of P or Q, which is a false statement, Then let's apply also this one. Negation of P or Q is a false statement. Let's go there. Then the negation of P or Q by associative property of disjunction, associative property of a disjunction, we can write in such a way. So which is the same as false. But what does it mean? Negation of P or negation of P? Negation of P or negation of P is one. On the or statement, the negation of P or negation of P is negation of P itself. Is that not? This one is negation of P or Q, which is equivalent to false. But what is the equivalent statement of P or negation of Q? The equivalent statement of P or negation of Q is P implies Q. P implies Q is false. In the case of implication or if then logical connective, the truth value of the compound statement P implies Q becomes false if and only if the truth value for the second statement Q is false and the first statement is true. Is that right? Therefore, the truth value for P is true and the truth value for Q is false. So which one is the choice? A is true, B is true, false, C is false, D is false, true. Therefore, the truth value of this one is this one. Well, B is a correct solution. The next one is let P and Q be statements. Then P by plus Q is logically equivalent to which one? Which one is P by plus Q is logically equivalent to which one of the statement? P and Q are the statements. So P by implies negation of Q. P by implies negation of Q is logically equivalent to which one of the following? So the first one is negation of P implies Q. Have you seen? P by implies negation of Q is logically equivalent to which one? Negation of P by implies Q. B negation of P by implies negation of Q. C P by implies Q, and D none. Which one is it? So clearly, you can see that the equivalence of the statements. We can observe the equivalence of the statements for P by implies Q. P by implies Q. You have the given, then logically in which statement it's equivalent. Clearly, the truth value for this compound preposition becomes true if they have the same truth value. P and negation of Q have the same truth value, so that which one is equivalent to this statement? Negation of P implies Q. Negation of P by implies negation of Q, and P by implies Q, and none of the other. We can see this one using the truth statement, or we can see other methods to show that a given statement is logically equivalent or not. So B, we have two statements P and Q. We can use truth statement: true, false, false, true, false, true, false, true, false. And the next one is negation of P is false, false, true, and negation of Q is false, true, false, true. This one. Now let's construct P by implies Q. P by implies Q becomes true. P by implies Q becomes true if they have the same. P P and Q have the same truth value. So true here, it has false statement here, it has false statement, and then here we have true statement. And the next one is negation of P by implies Q, negation of P by implies Q, negation of P by implies Q. So what will be the truth value for this one? The truth value for this one is negation of P is here by implies Q. Negation of P true by implies false is false, false by implies true is true, true by implies true is true, true by implies false is false. Yes? And the next one is negation of P by implies negation of Q. Negation of P by implies negation of Q. Negation of P by implies negation of Q. Negation of P, false, false, false by implies false is true, true by implies false, false, true by implies false is false, true implies true is true. And the last one is this statement. P implies negation of Q. This statement. So what will be P implies negation of Q? P implies negation of Q. True implies false, it's false. True implies true, it's true. And false implies false, it's true. And false implies true, it's true. So clearly, you can observe this choice. Negation of P implies Q, negation of P implies negation of Q, and P implies Q. You can see from the choices, this is the question, which one is equivalent to this statement? Which one is equivalent to this statement? False, true, true, true. True, false, false, true. This one is not. False, true, true, false. This one is false by implies true, which is this one is false. You can see false, true, true, false. This one is right. And the last one, true, false, false, true. This one is not. Therefore, the correct solution for P by implies negation of Q is negation of P implies Q. Negation of P implies Q, which is the first choice. A is the equivalent, logically equivalent statement for P by implies Q. B by implies negation of Q is equivalent to P by implies negation. P by implies Q. Negation of P by implies Q. The next one, a survey was conducted in a class of 100 children, and it was found out that 45 of them like mathematics, whereas only 35 like science. 10 students like neither of the 10 students neither of the subject. 10 students like both the subjects. 10 students like I think I should correct this question. 10 students like both subjects. 10 students like both subjects. 10 students like both subjects. Both subjects. Then the question is how many like neither. How many like neither of the subjects. Neither of the subjects. So clearly you can see that math students, let's say that it is 4 questions. This one is the same question. 4 questions. It's given that in a class, the universal seat is 100. The universal seat is 100. The universal seat is 100. Then from that, those who like maths are 45, and those who like science are 35. Those who like science are 35. Then and those who like both maths and science are what? Are 10. Those who like. Oh, so how many like neither of the subjects? Which is A union B. Our target is A union B complement. Our target required is A union B complement. So before finding A union B complement, let's find first what the union of A and B, which is A, M union S complement. So how can we find the number of M union S first? This one will be obtained. The number of M plus the number of science students minus the number of the intersection A and M intersection S. So which is 45 plus 35 minus 10, which is equal to how much? Which is 80 minus 10, which is 70. So 70 students like either science or mathematics, but neither those students who like neither of them is A, which is M union science complement, which is obtained by universal set minus the number of universal set minus A union M union S. So which is 100 minus 70, which is equal to 30. So 30 students does not like neither of the subjects. So the choice A is 40, B is 50, C is 20, D is 70. So 30 is a solution, but it's not found on the alternatives or on the choices of the questions, so that the exact solution is it has no solution. For the next question, the next one. For an NPT set A and B, for an NPT set A and B, if A is the proper subset of B, then which one is not necessarily true? Have you seen? For any non-empty set A and B, if A is a proper subset of B, then one of the following statements is not necessarily true. The first one is for all x, x is an element of A implies x is an element of B, which is A is a proper subset of B. X means that for all x, x is an element of A, and x is an element of B, and implies x is an element of B, and A is different from B. Number of A is different from B. So for all x, x an element of A implies x an element of B. So which way? For all x, x an element of A implies x an element of B. Not necessarily true. Yeah. There exists x an element of A, and x is an element of B. There exists x an element of A, and x an element of B. There exists x not an element of A, and x is an element of B. And there exists x an element of A, and x is not an element of B. Have you seen? For all x, x an element of A implies x an. Clearly, this one is true. There exists x an element of A and x an element of B, which is also true. There exists x an element of x not an element of A and x an element of B. Clearly true, because A is the proper subset of B. So B is at least one element greater than the set A, proper subset. So there exists x an element of A and x is not an element of A. This one is false statement. Therefore, from all the choices, the one which is not true is this one. Okay, let's continue the next question, which is number 6. Given the proposition P and Q, which of the following is not true? The first one, P implies negation of Q is equivalent to Q implies negation of P. Clearly, P implies negation of Q. It's contrapositive. The contrapositive is equivalent to its contrapositive. Which is the P implies Q. The contrapositive of P implies Q is what? Negation of Q implies negation of P. Is that right? So like that, the contrapositive of P implies negation of Q is Q implies negation of P. Therefore, this one is true. If P or Q is false, then negation of P implies Q is true. Is that true? So if P or Q is a true statement, it's also a false statement. It's given P or Q is a false statement, then negation of P implies Q is equivalent to P or Q. equivalent to P or Q, which is the same as this one, Therefore, it's not true, it's not true, it's not true, it's not true. If P implies Q implies negation of P is false, then P by implies Q is true. Let's check that. P implies Q implies negation of P. P implies Q negation of P, which is a false statement, which false. Then P negation of P or Q implies negation of P, which is false. And when we are applying equivalent statement for implication, similarly, negation of P or Q, negation of P, which is equivalent to false statement, which is equivalent to false statement, So which is the same as P applying negation here, P and negation of Q, or negation of P is equivalent to false. So applying distributive property, P or negation of P and negation of Q or negation of P is equivalent to false. It's given false statement. P or negation of P or negation of P is always what? Is false. Is always true, which is always true statement, and negation of Q or negation of P, which is equivalent to false. Now, true and this one statement, when two simple prepositions connected by and, the compound preposition becomes true if both statements are true. Therefore, it depends on the value of this one. If it is false, it becomes false. If it is true, it becomes true. Therefore, this result is negation of Q or negation of P is equivalent to false. Now, also, on the case of disjunction, the compound preposition connected by or becomes false if both statements are false, which means that negation of Q should be false and negation of P should be false, which means that P should be true and Q should be true. Therefore, P by implies Q is true, which is a true statement. And P by implies Q is equivalent to this one, which is also true. Therefore, the false statement is choice B. The false statement is choice B. Which of the following is always true where the universal set is the set of real numbers? The next question. Question 7 says, which of the following is always true? If it's given that the set of universal set under the set of it. The first one, for all x, for all y, x squared greater than y squared imply x is greater than or equal to y. Is it true? For all x and for all y, is it possible that x squared is greater than y squared implies that x is greater than, let's make this system with one counterexample, which is let's take x is minus 1 and y is 1 over 2. Then what would be x squared and y squared? X squared is 1, x minus 1 squared is 1, which is clearly greater than equal to 1 over 2 the whole square, because 1 is greater than 1 over 4. Clearly this one is right. But is that minus 1 is greater than or equal to 1 over 2? Is that this one? No. Therefore, this statement is a false statement. This statement is a false statement. There exists x for all y, x is greater than y is true. There exists x for all y. There exists a unique x for all y says that x is greater than y. Under real number, under the set of real number, we cannot find a unique number x0 such that for all x and for all choice of y in the set of real number, x is greater than y. This one is also false statement. And the C choice, for all x, we can find corresponding y, x is greater than y is true. Clearly right. For every choice of x, we can find corresponding y, says that x is greater than y, and this one is true. This one is true. Then the D choice, for all x, for all y, x squared is equal to y squared implies that x is equal to y. Is that possible? X squared is equal to y squared implies that x is equal to y. Does it true? Is it possible to say this one for every choice of x and y? I don't think, because if you choose minus 1 square is equal to 1 square is equal to 1 is equal to 1, but we can just say minus 1 is equal to 1. Minus 1 cannot be equal to 1, cannot be equal to 1. So this is statement is false. So the statement which is always true is choice B. The statement which is always true is B. And the last question, which of the following is false about the set? The set A, input set, the set contains input set A, B, and on the brass A. Therefore, which of the following is false? Which of the following is false about this set? The first one, input set is an element of A. Clearly true. Input set is an element of A because this one. 2, under two brasses input set is a subset of A. Is that? Input set is a subset of A. No need of, because this is not, it is not an element in set A. Therefore this one is not true. This one is a subset of it clearly because an element, it's an element. Singleton sets are subsets of the given set. And singleton elements of the set are subsets of the set. And this one, A is an element in set A. A is an element. Clearly this one is A is an element in set A. Therefore the one which is not. So the next question is show that the following argument is valid using rule of inference. So P implies S implies negation of R is the first one, and P implies R is given and P is given as a premises. Then shows that negation of S is also a true statement. So using a rule of inference, they show that the given argument. So an argument is a sequence of statements, and the first part of the statements are said to be the premises or hypothesis, and the last part is said to be the conclusion. And to show the given argument is valid, we start with the premises, taking that they are all true. And then if we find the conclusion, taking that these all are true, if we find the conclusion is true, then that argument is said to be a valid argument. That argument is said to be valid. Otherwise, it's invalid. And to show the validity of the given argument, we use different techniques. Using truth table. In truth table, we have two ways. One by finding the critical rows, and the other one is applying implication, conjunction implication. And conjunction implication, which means that finding a critical row means that after constructing the truth table for the argument, we are going to find those premises such that all the premises are true. We are going to find rows from the table such that all rows are true. Those rows are said to be critical rows. All premises are true. Premisoቹ ሁሉም true የሆኑበትን ሮዎች እንመርጣለን ማለት ነው። ፕሪሚሶቹ true የሆኑበትን ሮዎች መርጠን ፕሪሚሶቹ true የሆኑ ሲሆነው ኮንክሉዥኑ true የሚሆን ከሆነ that argument said to be true ማለት ነው። that argument said to be ሌላኛው ኮንጃንክሽን እና ኢምፕሊኬሽን ተጠቅመን ኮንጃንክሽን እና ኢምፕሊኬሽን እነዚህ በኤንድ እና የይዛቸውና then implies this one imply የሚያደርግ ከሆነ የእነዚህ true imply የሚያደርግ ከሆነ ከኤስ ጋር then that tautology ከሆነ ይሄ ቴብል tautology ከሆነ this one and this one implies negation of S, tautology ከሆነ then that argument is said to be a valid argument. And the second one is using the rule of inferences. Using rule of inferences, there are different rules of inference. So using those rules, we can show the given argument is valid. So the question restricted us to use rule of inferences. Therefore, we make all the premises as true. So P implies S implies negation of R is the true statement because it's a premises. It's a premises. 2P implies R is true because it's also premises. 3P P is true because what? Because it's a premises. It's a premises. And the fourth one, if P is true and P implies R is true, then what about R? R is what? R is a true statement. R is true. R is true by 2 and 3. By 2 and 3. By 2 and 3. Or you can use the most of tones. And 5 is if P is true and P implies S implies negation of R is true, then S implies negation of R is true by 3 and 2, by 3 and 1. By using 3 and 1, we can say that S implies negation of R is also true. And R is true, which means that negation of R is false, so that S implies false is true. So what will be S? So 6, S is a false. S is false by what? By 4 and 5. By 4 and 5. By 4 and 5. And 7 negation of S is what? Is true. Negation of S is by true by property of negation, or by property of negation by 6 and applied negation. By 6 and negation of 6 becomes so clearly it shows that it's a true statement. It shows that therefore this statement is valid. This argument is a valid argument. So thank you for watching this video. We'll come next video with another sample exam, so that please follow me by subscribing, like, share, comment on the video lectures. If you have any question, please write on the comment part. If you have any question, please write on the comment part. Thank you.